Welcome students. Today we are going to see exercise 1.3 and 1.4 of our first chapter, number system. And just we recall what we have discussed in our earlier class. And now we will see what is rational and irrational number and what are the difference between them and how to find which is rational and which is irrational. So here, for natural numbers 1, 2, 3, 4, 5, if you take square root, you see what happens. Square root of 1 is 1, square root of 2 is 1.4142, etc. Root 3 1.732050, etc. Root 4 is 2, that you know. Root 5 2.23606, etc. So you see, if you take square root, the type of number either rational or irrational. Root 1 is 1, that is rational. You can write 1 as 1 by 1, that is p by q form. Whereas root 2, after the decimal point, it is non-terminating and non-repeating. So, irrational. Root 3 also the same way. After the decimal point, it is non-terminating and non-repeating. So, it is irrational. And come to root 4, that is 2, terminates. So, it is rational number. And root 5, 2.23606, etc. Therefore, it is non-terminating and non-repeating. So, irrational number. So, generally we can say a decimal expansion. In decimal expansion, if the decimal, after the decimal, the digits are non-terminating, repeating comes under rational, and non-terminating, non-repeating comes under irrational. And now you see terminating and non-terminating decimals. The decimal expansion of a rational number is either terminating or non-terminating recurring. Recurring means repeating. These are rational. If irrational number means irrational numbers are non-terminating and non-repeating. So these are the decimal expansions. So what we have seen so far is the difference of rational and irrational. And if you take square root of a non-square number, for example root 7, definitely it is a irrational number. Root 9, the answer is 3, so which is rational. So if you take the square root of a non-square number, or you can say non-perfect square, square root of a non-perfect square is irrational. Okay, children? And now, what about the value of pi? So you always use the value of pi in measurement. But is it rational or irrational? Let us see that. About irrational numbers, that is about pi. Pi is defined as the ratio of the circumference of a circle to its diameter. That you know, pi equal to c by d. As pi is in the form of a ratio, there is no common unit to measure the circumference and diameter of the circle. Either c or d should be irrational if we want to measure accurately. So pi is regarded as irrational. And the Greek genius Archimedes first computed the value of pi, and he showed the value of pi lies between 3.140845 and 3.142857. The great Indian mathematician and astronomer Aryabhatta found the value of pi correctly to 4 decimal places, that is 3.1416. But after that, the value of pi, the decimal expansion of pi, is non-terminating and non-recurring. You see here, for how many decimal places? 3.141592 is non-repeatedly it is going. So pi is an irrational number. An approximate value of pi is 22 by 7. We use this in mensuration. If you write 22 by 7, it is not accurate. So 22 by 7 is in P by Q form. So you can say it is rational. But if you find in decimal, then pi is irrational. And Pi Day is celebrated every year on March 14. On behalf of the birthday of Albert Einstein. So this is the information for you. And now, just we recall how we can locate the irrational number like root 2, root 3, root 5 and more than that on a number line. First, this is for root 2. Here, representation of root 3 on a number line is given. But the first step, root 2. And then you see how we can locate root 3. So first, the number line, minus 2, minus 1, 0, 1, 2, like that. We have to take the units. And 0 you name as O. And unit 1 as B here. And OB is now 1 unit distance. 1 unit distance, I already informed you. You can take 1 unit as 2 centimeter. And now, at B, draw a perpendicular BA, the same 1 unit, either by compass method or using protractor. And now you join OA, so which is nothing but root 2. So this OA radius, the measurement is the value of root 2. And suppose if you draw an arc, taking the compass pointer at O and OA radius, if you draw arc, then it will be between 1 and 2, and that point on the number line is the value of root 2. And next, and now you see how we locate root 3 on number line. So the same number line. First of all, root 2 we have to locate, and then move to next root 3. So now, after getting root 2, at A, we have to draw a perpendicular to OA. This is OA. And AD is the perpendicular to OA. And AD, the measurement is 1 unit. And you join OD. And OD gives the value of root 3. And if you draw arc by keeping the pointer here and radius OD, and if you draw arc, then it will meet the number line at a point which is nothing but the location of root 3. And you see how it is drawn. The arc O, D, O as center, and the arc is drawn to meet the number line at C. Now the point C on the number line is the location of root 3. And we can take this triangle OAD, which is nothing but a right angle triangle here 90 degrees. So by using the Pythagoras theorem, OD square is equal to OA square plus AD square. So likewise, already I have explained clearly in the previous class. So using the Pythagoras theorem, we can get OD equal to root 3. Here you can see the below the line, you can see how they got root 2. That is OA root 2 using the Pythagoras theorem. So OA equal to square root of OB square plus BA square. You see, OB square plus BA square. So OA equal to root of 1 square plus 1 square and OA equal to root 2. Likewise, we can take OAB, the rectangle triangle, and by applying the same hypotenuse, we can get OD equal to root 3. Okay. And now you can see how to locate root 5 on number 9. So OA, 2 units you have to take. The direct method, OA, 2 units, and at A, draw a perpendicular EAB for 1 unit. So OA equal to 2 units, AB equal to 1 unit. Now you take OAB, the right triangle, by applying the hypotenuse, OB square is equal to OA square plus AB square, and OA is 2, so 2 square, AB is 1 unit, so 1 square, and this becomes 4, and this becomes 1, so 4 plus 1, 5. So OB square is 5, therefore OB equal to root 5. So OB equal to OP, that is equal to root 5. So now we can see the point P here on the number 9, which represents root 5. So this is the direct way of locating root 5 on number 9. It is supposed they are asking 2 mark question. You can directly do this method. Okay, and you see here. So this is the square root spiral, which I already explained in the previous class. So first of all, we have to construct root 2 by taking OA 1 unit and AB perpendicular to OA, and this AB also 1 unit, and if you join OB, that is root 2. And again you have to proceed, draw a perpendicular BC to OB and join OC, and which is nothing but root 3. And again at C, draw a perpendicular CD for 1 unit and then join OD, then you get OD root 4. So like that you can proceed, and here again from D, draw a perpendicular DE and you join OE, and then you get root 5, which is OE. So like that. If you draw arc for every radius OB, if you draw, it will leave the number line at a point which represents root 2. And for OC, if you draw arc, you get the point on the number line, that is root 3. And if you draw arc for OD, you get root 4, which is nothing but 2. You see, I have drawn it already. So OD as radius, O as center. If you draw R, then it will meet at the point X, which is nothing but root 4. Root 4 is 2. Is it clear? And proceeding in this way, you can get root 5, root 6, like up to we can do by ourselves root 17, I think. And this will be shown in the diagram. And now children, you can easily see the square root spiral from root 2, root 3, and it proceeds up to root 17. So this is the square root spiral. So this is why I asked already to prepare as an activity. So you see first how they construct root 2 from O. From O, you take 1 unit OA and perpendicular AB 1 unit, and then you join to OB. And again from B, perpendicular to OB, that also 1 unit, and you join, that is OC, and you get root 3. And after that, like that we can take OC and CD perpendicular, that also 1 unit, and OC is root 3. And from D, you take perpendicular for measure 1 unit and join OD, you get root 4. Likewise, if you proceed by taking 1 unit perpendicular, the perpendicular line which is 1 unit measure, then you can get up to root 17. Is it clear? And now you see how to visualize a given decimal expansion on number line. Okay, it is nothing but the location of the decimal number. You see how. representation of real numbers on the number line through successive magnification. This is exercise 1.45. First you see, we can see 1.4. Visualize 3.765 on a number line using successive magnification. So first of all, you have to draw a number line from negative integers and then 0 and then positive integers. And now this value 3.765, you know, it lies between 3 and 4. That you know very well. Yes, children? Now, you take magnify 3 and 4, and from 3 to 4, you take 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9. You see the figure 1. So here, figure 1, figure 2, figure 3. Okay, first is number line, and then you see in figure 1, we have magnified 3 and 4. The 3 to 4, the number line is magnified. And now, the 10th place digit 3.7. In the number, decimal number 3.765, listen carefully, 7 is in the 10th place, 6 is in the 100th place, 5 in the 1000th place. And now you look at 7. So 3.7 is here. 3.7 is here. And 3.76 means the next 100th digit you have to focus, and that is 3.76. So 3.76 means definitely it lies between 3.7 and 3.8. So you have to magnify again 3.7 to 3.8. How? By looking the 10th digit, that is what? 7, and then 100th digit 6. So after 7, the 100th digit is 6. So you have to magnify 3.7 and 3.8 to get 6 in the 100th place. So you see here 3.7 and then 3.71, 3.72, 3.73 and so on, 3.78, 3.79 and 3.8. And now you look at the 1000th digit 5. After 6 it is 5. So after 6 to get 5 we have to magnify 3.76 and 3.77. Do you understand? And now again 3.76 we have to take on the left and 3.77 on the right, and between that 3.761, 3.762, 3.763, 3.764, 3.765, 3.766, 3.767 and so on, 3.77. And now you see here 3.765, which is the required number, and you got it. Clear, children? And the second question is of 1.4 exercise. The second question is visualize 4.26 bar on a number line using successive magnification. So 26 upon that bar is there. So in the previous class I explained about the bar upon the digits. So for 2 and the 6, for 2 digits the bar is represented. So that means what? After the point 26, 26, 26, etc. The 2 digits are repeating 26, 26, 26. The bar represents that the 2 digits are repeating. So it is written as in short 4.26 bar. And now how to represent this on a number line? By using the successive magnification. So first of all you take the number line from negative integer to positive integer, and now you look at the figure 1. So this is the figure 1, and here by observing that 4.262626, so up to 4 decimals only you can try. Okay, 4 point, you see here the rounded digit, the rounded number 4.2626, like that, up to 4 decimal places we can try to visualize up to 4 decimal places. So you see, so 4.26 means we have to magnify 4 and 5. Between 4 and 5 we have to magnify. So you see here 4, 4.1, 4.2 and so on 4.9 up to 5. And in the second figure 4.2 to 4.3 it is magnified. Then only we can get 6. 4.2 after that the 100 digit is 6 there. So to get that we have to magnify 4.2 and 4.3. So within that we have to magnify 4.2, 4.3. So you see in the figure 2, 4.2, 4.21, 4.22 and etc. 4.29 and last 4.3. So each 10 divisions. Sir, and now after that to get the third place after the decimal again 2 you have to get. So for that we have to magnify 4.26 to 4.27. So you see 4.26, 4.261, 4.262, etc. 4.27. And again, if you try for 4.2626. So now 4.262 where it is here. 4.262 is here. So after that you have to get 6. For that you have to magnify these two. 4.262, 4.263. Okay, children. Now you magnify this. You get 4.262 and then 4.2621, 4.2622, 4.2623, likewise here 4.2626 and so on after that 4.263. So now the rounded number is the required decimal number. And now coming to the exercise 1.3. The first sum, we have to say whether the given rational numbers are terminating or non-terminating repeating decimals. What kind of decimals it is, we have to say. So the first option 36 by 100 it is given, and you know in the denominator 100 means you have to place the point before 2 digit. So 0.36, 36 by 100 is 0.36. So therefore it is terminating, it ends. So it is terminating decimal. And now you take the fourth option, it is given 3 by 13. It is a P by Q form, 3 by 13. It is rational, but we have to say the decimal expansion. So what kind of decimal? So whether terminating decimal or non-terminating repeating decimal. So you have to say by dividing it after finding the decimal value. So just I am dividing 3 by 13. You see in the dividend I put 3 and after that point I am 0, 0, 0. So it is equal to 3 only. And the divisor is 30. And now you start dividing. First of all, the 3 is not enough. So 30, the divisor is greater. So you put 0 point and then you add 1 0, that becomes 30. And in 30, 2 13 are there. 13 2s are 26 and the remainder is 4. This divisor you already know, but even though to get the decimal value, you have to do this. After getting the remainder 4, you take 0 and now becomes 40. In 40, 3 13 are there. 13 into 3, 39. And the remainder is 1. You put 1 0, you add 1 0, it becomes 10. Still, it's not enough because the divisor is 13 greater than 10. So again we have to put 0. Further we add 0 here. And then we put 0. Now it becomes 100. And now in 100, how many 13? 7. 13 on 13 7s are 91. And the remainder is 9. And you take add another 0. Now it becomes 90. In 90, how many 13? 13 6 are 78. So the remainder is 1. And now you put 0. And now it becomes 120. And how many 13 are there in 120? 13 9s are 117 and the remainder is 3. And again you see here the remainder is repeating. The remainder is repeating. You look here very carefully. The 3 is the remainder here and the first 3 starts from here. So again you put 0, it becomes 30 and 13 2s are 26. Again you get remainder 4. You see here the remainder is 4. Here also 4. The same thing will repeat again. The same remainder will repeat and the same portion, the decimal value, the same digits will be repeated. So you can start up to that. If you get the same remainder, you can start up to that and you see 230769, again 230769, like that it proceeds. So you can put bar like this. After the point 1, 2, 3, 4, 5, 6, how many digits are repeating? 6 digits are repeating. What are they? 230769 and again you get 230769 and again 230769. So you can put bar. The bar represents 6 digits are repeating. So this is called non-terminating repeating decimal number. Clear? And now you see in the same question, option 2, option 3, option 4 we did, option 5, option 6. So these are the other 4 options you take as common. You see here, this is 4 1 by 8. It is in mixed form. So you convert this to improper form. So what will come? 4 into 8, 32 plus 1. 33 by 8. And again you divide and find what kind of decimal expansion it is. Okay. So this is the first sum. And now you move to the second sum. It is given that 1 by 7 equal to 0.142857 mark. So it is given in the question 1 by 7 is equal to 0.142857. It is repeating. That 6 digits 142857 is repeating. So they put bar upon that. And can you predict what the decimal expansions are? 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7 without dividing, without doing the long division. We have to say the answer of 2 by 7 right. So 2 by 7 you can say 2 into 1 by 7 and it is nothing but 2 into, you can take this number 0.142857. Look, 2 by 7 we can write as 2 into 1 by 7 and 1 by 7 is given 0.142857 bar. And now you just multiply this. 7 into 2, 14, 4, carry 1. 5 into 2, 10, plus 1, 11, 1 and carry 1. 8 into 2, 16, again plus 1, 17, 7, carry 1. And then 2 into 2, 4, 4 plus 1, 5. And then 4 into 2, 8. And then 1 into 2, 2. And then point, and then 0. 0 into 2, 0. And then you put bar for this. 285714. Just we multiply by 2 all these digits and put bar because these digits will repeat. So 2 by 7 is equal to 0.285714. So like that we can do 3 by 7 as 3 into 1 by 7. 3 into what is 1 by 7? 0.142857 bar. And if you multiply, you can get, multiply by 3 and put 1, you can get the value of 3 by 7. So what is that? 7 3s are 21, 1, carry 2, and then 5 into 3, 50, 50 plus 2, 17, 7, carry 1, and then 8 into 3, 24, 24 plus 1, 25, 5, carry 2, and then 2 into 3, 6, 6 plus 2, 8, 8, that's it. And 4 into 3, 1, 2, carry 1. And then 1 into 3, 3 plus 1, 4. And then point, 0 into 3 is 0. And this is the repeating digits. 4, 2, 8, 5, 7, 1. So likewise, for 4 by 7, you can write this as 4 into 1 by 7. And then 5 by 7, you can write as 5 into 1 by 7. And 6 by 7, you can write as 6 into 1 by 7. So they are asking all these values, and easily you can multiply by the numerator with 1 by 7. You can get like this. Okay. And now we move to the question number 3. So what is that? Express the following in the form P by Q, where P and Q are integers and Q not equal to 0. That is the condition for rational number. So P by Q form means what? Rational number. So the given decimal number, our duty is to tell the form of rational number. So the given decimal number we have to represent in P by Q form. The third question, first option, decimal expansion is given 0.6 bar. The bar represents the digit under the bar is repeating. So let us assume the given decimal as x. So x equal to 0.6 bar, and that we can write as 0.6666 etc. and then it has equation 1. Multiply equation 1 by 10. Why should we multiply by 10? Since one digit is repeating. How many digits are repeating in the repeating block? One digit. So multiply by 10. If 2 digit repeats, multiply by 100. If 3 digit repeats, multiply by 1000. Okay, this is the way. So here multiply by 10 on both sides. You get 10x equal to 6.6666. While multiplying by 10, the decimal point move forward 1 digit. So you are getting this. And name it as equation 2. Now subtract 1 from 2. That is equation 2 minus equation 1. Left hand side minus left hand side. Right hand side minus right hand side. So 10x minus x, that becomes 9x. And here this becomes 6. I did here, you check it. 6.6666 minus 0.6666. What do you get? What do you get? 6 only. So 9x equal to 6. X equal to 6 by 9. And x equal to, after simplification by 3 table, we get 2 by 3. So that is x 0.6 bar equal to 2 by 3, which is in P by Q form. So that is the question they are asking. The given decimal, we have to convert to P by Q form. So this is equal to 2 by 3. And now coming to second option, 0.471. Only for 7 bar is there. That means what? After 4, 7 only repeating. So you take x equal to 0.47 bar. That is equal to 0.47777. Only 7 is repeating because the bar is only what? 7. And then it has equation 1. And now only 1 digit is repeating, as I told you earlier. You multiply by 10 and you get 10x equal to 4.7777. You name it as equation 2. Here, you focus on the decimal part. Here, after 0.477. Here, after 0.77. So they are not equal in decimals. Decimal part is not equal. So further, you multiply this second equation by 10 and you get 10x into 10, 100x, and here one place forward the decimal point will move, so you get 47.777. So now you see here the decimal parts are equal. So just I wrote here what we have to do, trying to make the decimal part equal. And after making the decimal part equal, we can do like this, like equation 3 minus equation 2. So because this is bigger, this is smaller. 100 is bigger, 10 is smaller. So from 100 we have to subtract 10. So 100x minus 10x left hand side, and right hand side 47.777 minus 4.7777. And here you get 90x, and here you get 47 minus 4. The decimal parts are equal, so it vanished. So remaining integer part is 47 here. So 47 minus 4 is 43, and you get 90x equal to 43, and so x equal to 43 by 90. So 46 0.47 bar, that is equal to 43 by 90. Okay, children, do you understand? And now coming to the third option of question number 3, 0.001 bar. So here 3 digit is repeating because the bar is under 3 digits. So 0.001, 001, etc. That is equation 1. Multiplying 1 by 1000 because 3 digits are repeating. So multiply by 1000. You get 1000x equal to, you see here, from here the decimal is moved 1, 2, 3 places. You get 1.001, 001, etc. And then it has equation 2. Now equation 2 minus equation 1, you get 1000x minus x, which is equal to 1.001, 001 minus 0.001, 001. And now this becomes 999x, and here the decimal parts are equal, so it vanishes. The remaining the integer part is 1. When you subtract, you get 1. And x equal to 1 by 999. So 0.001 bar equal to 1 by 999, which is in P by Q bar. So in all these exams, the given decimal expansion is converted to P by Q bar. Now coming to question number 4. Making sense this question. What sense it's making? Let us see. The given decimal is 0.9999. So we assume that as x and put equation number 1. Here 1 digit only repeating, so multiply by 10. So you get 10x equal to 9.9999, etc. And then it has equation 2. From 2 you subtract 1, and you get 10x minus x is equal to 9.999 minus 0.999. So this becomes 9x equal to 9. The right side, the equal decimal part, so we get only 9. X equal to 9 by 9, which is nothing but 1 by 1 equal to 1. So that means what? The given decimal 0.9999 is nearly equal to 1. Nearly. Not exactly, but nearly. So this is the sense making question. And now coming to question number 5. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of the given rational number 1 by 17? So the denominator is 17. So denominator of 1 by 17 is 17. So you have to subtract 1. That means 17 minus 1 equal to 16. So this is the method to find the number of digits which is repeating in the decimal expansion. So now we can have 16 digits will be in the repeating block of digits in the decimal expansion of 1 by 17. So by this way we can find the answer. And generally n is the denominator, means of a given rational number, then n minus 1 digits will be in the repeating block, provided that it is a non-terminating repeating decimal. So this is the general. If any rational number, the denominator you have to take the and less than 1 the denominator. For example, if there is the denominator is 18, then we can say something like that here 17, so 16. So less than 1 of the denominator. That is the digits will be in the repeating block. And coming to question number 6, P by Q, the given rational number, general form, and denominator Q not equal to 0. P and Q are integers with no common factor other than 1. That means what? 1 is the common factor. 1 alone is the common factor. No other common factor. And having terminating decimal. That also you mind. Terminating decimal. Then what about Q? Q means denominator. For example, take 1 by 2, that is 0.5. 3 by 2, 1.5. 4 by 25, 0.16. 17 by 100, 0.17. In all these P by Q form rational number, the common factor of P, Q, that means here 1, 2, and here 3 and 2. The common factor is 1. That's power and 25. The common factor is 1. 17 and 100. The common factor is 1. So such rational numbers, and if it is terminating decimal, then what about Q? What you can say about Q? That means 1 by 2 you can write as 1 by 2 power 1. 4 by 25 you can write as 4 by 5 square. 17 by 100 you can write as 17 by 4 into 25, where 4 is 2 square. 25 you can write as 5 square. So in all these you look at the denominator. Here 2 power 1, here 5 power 2, here 2 power 2 into 5 power 2. That means what? Any rational number which is terminating, then the denominator Q will be of the form 2 power m. That means 2 is the base with any power, or 5 power n, or both 2 power m into 5 power n. So 2 with power anything and 5 with any power. So like that you see here, here and here. So these are the properties of Q. Some we will see in the next class. Thank you.